Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from three-dimensional geometry related to finding out the equation of a plane, right? And here we have to find the equation of a plane which passes through a given point which is minus 1 comma 3 comma 2 and perpendicular to these two given planes, right? So here we are given a point whose coordinates are minus 1 comma 3 comma 2, and we have to find the equation of a plane which is perpendicular to these two planes, right? So let us start. So now we know that the equation of a plane is given by ax plus by plus cz plus d is equal to 0, right? So this is the general equation of a plane, right? But here we are given a point which lies on this plane, right? So here we have a rough diagram of this plane. Let us call this plane as plane P, right? And we are given the point minus 1 comma 3 comma 2, right? So the equation of a plane which passes through some point, say x1 y1 z1, is given by a times x minus x1 plus b times y minus y1 plus c times z minus z1 is equal to 0, right? So this equation can be modified to this equation when we are given a point on the plane, right? So this point is x1 y1 z1, right? So here x1 y1 z1 is minus 1 comma 3 comma 2. So let us substitute the values of x1 y1 and z1 in this equation. So we'll get a, and here we have x plus 1, and here we have b, and y minus 3, and c z minus 2 is equal to 0, right? So the equation of the required plane is given by this equation, right? So here we need to find out the values of a, b and c, right? And we know that these numbers a, b, c are the direction ratios of the normal to this plane, right? Suppose this is the normal vector to this plane P, right? So the direction ratios of this normal vector are given by the coefficients of x, y and z, right? So here we have a, b and c, right? So now we need to find out the values of a, b, c, and to get the values of a, b, c, what we will do, will make use of this condition, that is this plane P is perpendicular to these two planes, right? So now let us call this plane as P1 and this plane as P2, right? And the normal vector to this plane P1 is denoted by vector n1, and the normal vector to this plane P2 is denoted by n2, right? So the direction ratios of this normal vector n1 is given by the coefficients of x, y and z, right? So the direction ratios of this vector n1 is 1, 2 and 3, right? And the direction ratios of the normal vector n2 are given by the coefficients of x, y and z. So here we have 3, 3 and 1, right? So here we have the coefficient of z as 1, and here we have the coefficient of x as 1, right? So now here we are given that this plane P is perpendicular to this plane P1, right? And this plane P is also perpendicular to the plane P2, right? And we know that if two planes are perpendicular, then their normal vectors are also perpendicular, right? Suppose we have a plane and we have some another plane, say this is the another plane, right? And if these two planes are perpendicular, then their normal vectors like this, this is the, say this is the vector n2, and this is the vector n1, right? So when these two planes are perpendicular, then their normal vectors are also perpendicular, right? So when P is perpendicular to P1, it implies that this vector n is also perpendicular to the vector n1, right? And when this plane P is perpendicular to P2, then the normal vector n is also perpendicular to vector n2, right? So now the direction ratios of the normal vector n are a, b and c, and this vector is perpendicular to n1. So here the direction ratios of the normal vector n1 are 1, 2 and 3, right? And similarly here vector n is perpendicular to n2, so the direction ratios of vector n are a, b and c, and this is perpendicular to n2 vector, so the direction ratios of n2 vector are 3, 3 and 1, right? Now from vector algebra, we know that when two vectors are perpendicular, then their dot product is 0, right? So n dot n1 must be equal to 0, and n dot n2 is also equal to 0, right? So from vector algebra, we know that when two vectors are perpendicular, then their dot product must vanishes, right? So here first we'll take this one, that is vector n dot vector n1 is equal to 0. So we'll multiply a with 1, that is a dot 1, or a multiplied 1, then we have b times 2, and then we have c times 3, right? And from here we have a multiplied with 3, b multiplied with 3, and c multiplied with 1, that is equal to 0, right? So now we have two equations, that is a plus 2b plus 3c is equal to 0, and from here we have 3a plus 3b plus c is equal to 0, right? So let us denote these two equations by equation 2 and equation 3. So now our next aim is to solve these two equations, right? So here we have two equations and we have three variables a, b and c, right? So in order to solve these two equations, what we will do, we'll select any one variable and we'll eliminate that variable from these two equations, right? So here let us multiply this equation 3 by 3, right? So that here we'll get 3c, and when we subtract these two equations, then c can be eliminated, right? So now we have a plus 2b plus 3c is equal to 0, which is equation number 2, and the third equation is 9a, because we are multiplying this equation by 3, so here we have 9b plus 3c is equal to 0. Now let us subtract these two equations. So 3c and 3c get cancelled, so we have a minus 9a is minus 8a, and here we have minus 7b is equal to 0. So now we can write minus 8a is equal to 7b, and we can also write this equation as a over 7 is equal to b over minus 8, right? So this is a very important step. So now here what we will do, we'll introduce a scalar, say a lambda, right? So what we will do, we'll write a over 7 is equal to b over minus 8 is equal to lambda, and the purpose of introducing this scalar lambda, which is not equal to 0, is to express A and B in terms of lambda, right? So from here we have A over 7 is equal to lambda, and B over minus 8 is equal to lambda. So A is 7 lambda and B is minus 8 lambda, right? And now we'll substitute A and B in either of these two equations. So let us substitute A and B in equation number 2. So here we'll get 7 lambda, and here we have 2 times minus 8, that is minus 16 lambda, plus 3c is equal to 0. So this is minus 9 lambda plus 3c is equal to 0. So 3c is equal to 9 lambda. So c is equal to 3 lambda, right? So now we can write this equation as c over 3 is equal to lambda, right? So now we can write the value of lambda as c over 3 in this equation. So now we have a over 7 is equal to b over minus 8 is equal to c over 3, right? So now we have this equation. So now from this equation, we see that the direction ratios of the normal vector n are 7, minus 8 and 3, right? So from this equation, we can claim that the direction ratios of the normal vector n are given by 7, minus 8, 3, right? And now we can substitute the values of a as 7, b as minus 8 and c as 3 in equation number 1 to get the value of or get the equation of the plane P, right? So now the equation of plane P is 7 times x plus 1, then we have minus 8 times y minus 3, and 3 times z minus 2 is equal to 0, right? Now we can simplify it. So we have 7x plus 7 minus 8y plus 24 plus 3z minus 6 equal to 0. So this is 7x minus 8y plus 3z, and here we have 24 plus 7, 31, and 31 minus 6 is 25, right? So the required equation of this plane P is given by 7x minus 8y plus 3z plus 25 is equal to 0, right? Now here I would like to mention one important thing. See, here we have taken A is equal to 7, B is equal to minus 8 and C is equal to 3, right? So we can also do another thing, that is if we write this equation as A over 7 is equal to B over minus 8 is equal to C over 3 is equal to lambda, right? Because a over 7 is equal to b over minus 8 is lambda, and c over 3 was also equal to lambda, right? So from here we can write a is equal to 7 lambda, b is equal to minus 8 lambda, and c is equal to 3 lambda, right? Where lambda is some scalar quantity and that is not equal to 0. Now if we take the value of a as 7 lambda here, then b is minus 8 lambda over here, and c is equal to 3 lambda over here, then we'll get the same equation, right? So let us find the equation. So now equation 1 can be written as 7 lambda, here we have x plus 1, then we have minus 8 lambda, y minus 3, and then we have 3 lambda, and z minus 2 is equal to 0, right? Now if we take lambda as common, then we have 7x plus 7, and here we have minus 8y plus 24, and then we have 3z minus 6 is equal to 0, right? So now, as we have already said that this factor lambda is a scalar and not equal to 0. right? So this factor must be equal to 0. So now we have 7x minus 8y plus 3z, and here 24 plus 7 is 31. 31 minus 6 is 25, right? Which is the same equation as we have derived earlier, right? So this is the required equation of this plane P, which contains this point minus 1 comma 3 comma 2, and this plane is perpendicular to these two given planes. And here we see that the direction ratios of the normal vector n to this plane P are 7, minus 8 and 3, right? So if we wish to write the equation of this plane in a vector form, then we can write 7 I cap minus 8 j cap plus 3k cap, and here we have vector r, and plus 25 is equal to 0, or we can also write it as r dot 7i cap minus 8j cap plus 3k cap is equal to minus 25, which is of this form, that is vector r dot vector n is equal to d, right? So viewers, this is how we can solve these type of problems related to finding out the equation of a plane in three-dimensional geometry.